Okay, so what we saw previously, before I explain all this, is we saw a situation, and in fact, let me go back to like this diagram here, okay? Um, if we think about having a certain index of refraction over here and a certain index over here, then the film, or the interior layer, is going to be, maybe we'll call it N sub I. All right. Now, what we have in this particular situation where it goes faster, slower, faster. All right. So on the outside, that N value is less than the inside, than the layer. Okay. But then on side 2, all right, that N value is also smaller. Okay, so the index of refraction of that interior layer there is greater than both of them, both of the outsides. Okay, so we might kind of call that sandwich, or we might call that symmetric. All right, it's greater than both. And so all of these conclusions that we got to deal with having a symmetric situation with our indices of refraction. All right. Now, it can also work as opposites. And what I mean is we could have this, where the index of refraction is smaller in the middle than on either side. So that would be like glass, air, glass. Okay. So as long as we've got some kind of sandwich thing, then these results here that we derived are good to go. Okay. But that's not all that there is. Okay. So we could have a situation like this, where we've got N1, N on the inside for our layer, and then N2 like this. Okay, now, if we're going slower, faster, even faster, then that means our indices of refraction are like this. Okay, and so I would call that an asymmetric thin film situation. All right, it's an asymmetric. But again, it could also be the other way. All right, instead of going slower, faster, even faster, we could go even faster, a little slower, and even a little slower. Okay, so we could be speeding up with every boundary or slowing down with every boundary. Now, at this point, the mathematics conditions are similar. Okay, so we've got destructive. It depends on having an odd number of pi, 1 pi, 3 pi, 5 pi, etc. And constructive is going to depend on phase differences being even numbers of pi, 2 pi, 4 pi, 6 pi, etc. Okay. The phase outside, okay, we go from slower to faster. All right. This time, actually doesn't have the pi on there. In this case, well, it depends. If we're slowing down, it's going to be on there. Okay, so that part is optional. All right, but what matters is we're going to end up subtracting the outside and the inside. Okay, and so whether we're going slower to faster to even faster, or fast to a little bit slower to even slower, the pi out here, whether it's there or not, doesn't matter. It's going to subtract away once we take a look at phi on the outside minus that first or that second reflection. Okay, the first reflection minus the second reflection. All right, and it gets us these results here. Okay, now those are going to look really familiar, and I haven't gone through it in as much detail. The difference is these are completely opposite of what we had earlier. Okay, completely opposite. So the same thickness, instead of giving you destructive interference, is going to give you constructive interference. Okay, or the same thickness, instead of giving you destructive interference, is going to give you constructive interference. Okay, sort of like that. So this is a little bit of a tricky element here, okay, because we've got the same two equations, but they represent opposite things, okay? So, but before I go forward more with that one, let me show you kind of an example, okay? We actually use this from time to time. If you've got a nice pair of glasses, okay, you might have paid extra for an anti-reflective coating on the glasses, all right? So these glasses down here have an anti-reflective coating on it. The ones up here at the top do not, all right? And you can see in the top one, you can actually see the guy in the camera taking the picture. And the ones at the bottom, it's really hard, if it even possible, to do that, okay? And so the deal is, your lens is made out of a certain kind of plastic, all right? And you put a thin layer of plastic over the top, okay? And you choose a sort of an average thickness on that. So you got a range of lambdas, one of which will experience perfect deconstructive interference. The others will be partial, okay? And even though they're not complete, they're still going to be reduced quite a bit, all right? So they might be 10 or 20% of the original, even if they're not zero. And that's going to make a big difference, okay? Now, why would you do that? Well, it's because if you have less energy coming out over here, then that means you've got more energy on the inside. Okay, so these glasses, when you look through them, they're going to appear to be a little bit, it's just going to be a little bit easier to see through them. Okay, some of you that hunt, you may have a scope for your rifle that has anti-reflective coatings on it. Okay, and the same thing, it applies there, that coating is actually going to allow more light to come through so that you can see better, what you're looking at. Okay, kind of like that. All right, so here's the situation. All right, so this is the one, this is the money shot. Okay, you might want to get a screenshot of this right here, okay, because we've got both of our equations here and here. All right, and in one case they provide destructive, in the other case constructive. All right, but they're opposites. So you got to look for, what's my situation? Do I have a sort of a sandwich situation where it's going to go fast, slower, fast again, or fast or slow, fast, slower again? That's the sandwich. That's the symmetric one. Okay. So see here, my N is greater than both, or my N is less than both. All right. Then I have that situation. All right. If my wave is going slowing down even more, or speeding up even more, then I've got these conditions here. Okay. Now there's not any real good way to keep those straight. Okay, maybe some of you are clever and you can think of some way to know which is which in which situation. Okay, but yeah, anyway, so I would definitely get a screenshot or write all that down right there. Okay, that relationship with T and lambda and the index of refraction. All right, that's going to get you a long ways on your homework and stuff. Okay, all righty, there we go, guys.